Good morning, everybody. Welcome to exciting Tuesday morning of Chem 1105 with your host, Dr. White. Uh, as you know, yesterday, if you don't, I'll tell you now, I had cataract surgery on this eye. You can see it's still dilated and still blurry. So if I talk like this with this eye closed, it's easier to focus right now. And let's see how long I'll go today. But I will have to say this, the surgical center, I think it's called Hoffman State Surgical Center. The nurses there were amazing. I mean, truly amazing. And I thank them and I'll thank them again publicly now. I'm going to find out who the manager is of that and I'll send an email thanking all the nurses. My eye surgeon was fantastic. One of the things that's a problem in my personality, I worry about how things can go bad. And until a couple of days ago, I was very anxious about this, operation on my eye. It's cataract surgery, and it's probably, I think, from my research, the most widely, uh, most common surgery in the United States, if not the world. But anyways, I researched my eye surgeon, and it also was recommended to me by someone whose family had used them personally, which is important. And finally, about 2 or 3 days ago, after going through what's all the bad things that can go on, well, I have to get a metal cup with pencils and sit somewhere and make a living that way. No, but anyways, uh, all that went through my mind. And finally, the chemist in me said, all right, you're a scientist, look at the facts, you investigated online, and it's nice you can do that online. Your surgeon, no major problems at all, no any problems at all. He's answered all your questions uh, and been nice about it. That's an important thing when you go to any medical doctor, dentist, or whoever. If they're not willing to answer your questions in a professional way, walk away. This guy did, and uh, it's still blurry. You can see my eyes still dilated. That's normal. Uh, I have an appointment at 3 this afternoon. He told me I can drive. Yes, I can drive myself. But I do have to apologize. After I got home yesterday, my best friend who took me there and picked me up stayed with me for about an hour and a half till I felt okay. And then he left. I went to sleep for a long time. I think it's the medication they give you. It's a sedative to relax you before the actual operation. And this morning when I got up, I just, so I haven't done the test key yet for your test number 3, which you all should have gotten back your scores in Blackboard. And also, hold on one sec, uh, the individual points. I will do that tomorrow. I'm feeling better. I got the rest of the day to knock that off, but I haven't. So what are we going to do today? I hope you all watched the video. What I like to do first is do the lab, and then also afterward, I'll do some organic, get going on that. Let's see how long I feel, how good I feel, how long we'll do. I'll do, but we'll get it all in. And I think that's about it. I better get, oh, one other thing. For the lab that's due today, I hope you got the message, omit part 6. There was an actual bug in the Beyond Lab Z lab, which they haven't fixed as last time I checked it a couple days ago. And so just omit part 6, step 6 of my procedure. That's where you add the second amount of the KHP. Don't do that, just whatever they weigh out to, and it'll work fine. If you haven't handed it in yet, I'll give you another week. Dr. White's being nice before I take off any points for being late. And today's Tuesday, so tomorrow, come to my office hour if you're having problems. And any questions? And with that, again, I'm going to change things a little different. Let's do today's lab. And first of all, I got to open up today's lab and a couple other things. Some reason my hard drive is slow today. I got too much stuff in this one folder, and that's the problem. Yeah, it should be interesting to see me write using one eye. I think I'll be all right. Ooh, I got to turn on my tablet. All right, let's get, it's on now. All right, let's get to work. Today's lab deals with titration of an unknown acid with a base. And as I mentioned before, and you did a titration last week's lab, when you add a certain amount of acid and base, they react together and they're neutralized. The pH comes to 7. Now, let's see how well I can write. Actually, I'm keeping this eye open for a while. Look out, I can write. You take an acid plus a base, you'll have a they'll react. You have proton transfer. Remember, an acid is a proton donor, base is a proton acceptor. And what you get is this salt, because you have a cation. Well, I'm doing pretty good. And an anion. I'm going to have to party hard tonight. Not. But anyways, when this happens, if you add a base to an acid or vice versa, remember pH, the scale goes from 0 to 14. In the center is 7, and this is neutral. I can spell, and my operation didn't improve that. And above 7, it's basic solution. Below 7, it's acidic. And if you start here with an acid and you add base to it, you'll go closer to neutral, which is why this is called this type of titration is called neutralization. Now, as I've mentioned, when you do a titration, this allows you to find the unknown molarity. Remember, molarity is moles of a solute per liter or 1,000 milliliters of an acid or base. In this lab, you'll be finding out the molarity of an HCl, unknown HCl solution. At neutralization, when the pH indicator changes color, the following is true. Moles of acid equal moles of base. Now let's talk about the indicator. A pH indicator is a chemical that has a different color depending on the pH of the solution. Let me say that again. A pH indicator is a special chemical that changes color when you have when you go from one pH to another. At a certain pH, it's one color. At another pH, it's another color. Now, for this lab, instead of the way they have this set up as a preset beyond Lab Z, I think we'll use methylthymal blue, which goes from a yellow to a blue color. The last lab used phenolphthalein, which goes from clear to a wine color or red. Now, when it changes color, that's called the end point of the titration. Why do they call it end point? Because you stop adding whatever you're adding to the unknown solution. In this case, you'll be adding sodium hydroxide. And therefore, the end point is when the pH color changes, or pH indicator color changes color, and you know moles of acid equal moles of base. Well, for a monoprotic acid and base, that means it can only give up one proton, it can only accept one proton, which HCl and sodium hydroxide, hydrochloric acid, sodium hydroxide, NaOH can. We know, first of all, milliliters of acid times molarity equal milliliters of base times molarity of base. Now, here, if we're trying to solve for the molarity of HCl, I've got to get rid of the milliliters of HCl, so I'm going to divide by it. Anything divided by itself equals the number 1. And whatever you do to one side, you have to do to the other. So we now come to equation 3, which you will be using in today's lab. The molarity of the HCl equals the milliliters of the NaOH, and you will be given on your bottle the molarity of the solution. You'll be using titrate NaOH solution. And here for this lab, it's preset. They have 25 milliliters. Oh, I forgot. 25 milliliters of HCl. And this lab, you'll be using the titration technique to determine the molarity of HCl. Now, when I went to, first of all, I'm doing good. Dr. White's back in the groove. Look out. All right. I'm happy about that. So you know what that means? Tea time. Oh, is that blueberry good? I'm not keeping this eye closed all the time. That's good too. All right. Now, I want to do the Beyond Lab Z Lab for what they now have on the HTML or internet version. I had a lot of trouble with it. They've got some bugs they still have to work out. And over the weekend, I just didn't feel like it. Sorry, but I didn't because of the upcoming this to contact them. I'll do that later today, but you're doing the lab today. So guess what? I went back to the desktop one, and it worked perfectly, just like it did this summer when we did it. So watch closely. First of all, I have log in to Beyond Lab Z. Then this is important, and I'm going to show you this. Click on the desktop, and then click on the chemistry link called Legacy. Now, if I already have it loaded on my file because I used this during the summer, and also last spring we used it for another class, but you may have to download some files from Beyond Lab Z. Follow those prompts. It's not that hard unless you have a very, very old Chrome booktop. You should have no problem with it. And, or I think very, very old, yeah, it's a Chrome booktop. Let me show you what you have to do. This will be in the video I'll post later today. All right, I haven't done it today, so thumbs up. Everybody see Beyond Lab Z on your screen? Let's make sure. Thank you, all the thumbs up people. Now, don't click here. See up front where it says on top, says desktop, click on that, watch. Now see where it says setting up connection? And if you haven't downloaded this part, you'll have to, I'm gonna hit connect because I already have it set up on this machine. And then just like when you're logging into Zoom, or at least I do, says choose application. And I'm going to choose Beyond Lab Z Connect 3, open link. All right. And it says, if you scroll down where it says legacy, click on open. All right, thumbs up, people. Does everybody see welcome to virtual Chem Lab? Thank you, Amber. Now, don't click on titrations. Let me go back to the lab. Then in the worksheet area, click on acid-base chemistry, which I have lower left of your screen. Then click on acid-base titration, unknown HCl. Let's do it. That's not what I want. That's what I want. All right. Thumbs up, people. Everybody see worksheets on the left. Thank you. Click on acid-base titration. Notice below, you'll see a number of choices. Use the sidebar to scroll down. And then right here, it says acid-base titration, unknown HCl. Again, use the sidebar to scroll down under acid-base titrations to acid-base titration, unknown HCl. Click on that. All right, now everything's set up. In your burette, you have sodium hydroxide. If you notice, the sample I have has 0.2564 molarity. You need to copy that down. And let me show you. Let's go back to the lab. Here I have a place, molarity of NaOH solution, and being the nice person I am sometimes, see simulation NaOH bottle, and you put down that number. Next, look at the bottle of HCl. There's an unknown number. Guess what? They use different unknowns, so not all of you will have the same molarity and HCl when you're done. If you notice, this simulation I just pulled up has unknown number 12. You need to write that down. Now, right here, they have everything you need to add in the burette and in the beaker. This beaker has HCl. If you notice, it's got a slight yellow color, and that's because it has the, I'm using the, I guess it's bromocresol green. I thought it was called blue. I usually use phenolphthalein, but they set it up. And over here on the upper left, you'll see the burette, and it's full. And see the meniscus there. It looks like the U in the liquid. At the bottom of the U, we're at 0.0, which if you go back to Here, initial burette reading, titration 1, 0.00. Now, they also have in here, and you've got an upper right mouse click this, and you can move it over here. This shows you pH, conductivity. I wouldn't worry about. I've never used successfully, even in a real lab. And here's the valve for the pH meter. Now, what you're going to see in the bottom of the beaker is it changed to very, very light blue. And that's what you stop at. Now, I don't know if I mentioned it last time, but for something like this, I don't know where the term started, but if you worked in QC labs, quality control labs, I've managed them, and I've worked in them. People were sick, I had to take over. The first time you do a titration like that to get a feel where the endpoint is, you add it real quick. And we call that shotgunning it in. How it got that name, shotgunning, I have no idea. And this is a secret, higher level chemist trick. Keep it a secret. You now know a secret. And I'm going to show you, first time, don't even write down data. And I didn't realize this, let's bring this over here. And you can control how fast or how slow. If you look at on the left over here, it's going in pretty quick. Now the blue line here, I can look at, and as soon as I see, which I can with both eyes, the left eye is sort of fuzzy, and you can slow down, and wow, did I hit it right. Now I just shotgunned it in. I see it's about 16 point, let's see, 2, 4, 6, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each one of these little lines is a tenth. So that would be 16.1, 2, 3, 5. 16.35 milliliters was halfway between 3 and 4. Remember the bottom of the U. Now I wouldn't write this down because this is my first attempt. Now what you can do is exit, click on unknown titration, acid-base titration, unknown HCl. I see there's a question. Actually, that would be called chugging. Actually, that comes from my fraternity days. Oh, it's time for a Dr. White story. Back when I was in a fraternity undergrad, we had 32-ounce mugs. I still have mine downstairs. And we'd have beer blasts with the other fraternities. And we'd have chugging races. We'd have 5 guys, and one guy had to chug it next, and they'd time it. And our house didn't always win, but of the individual, I could chug it the fastest. I could do a whole quart of beer in under 5 seconds. So I don't think shotgunning came from doing that, but don't tell anybody I told that story. All right, so we're set up again. We're back at 0. And now, since you know the secret, what I can do is open it and assume it's about the same. And now I am shotgunning it in. And here's the trick. When I get near 16, now I'm going to go real slow. I'll come back in 5 minutes. Maybe a little faster. Now I'm going to go real slow. Keep an eye on the beaker. Doing titrations is something you have to have patience. And there you go. Maybe one drop past it. And that's what you do. And now you record the final volume. Make sure you have the unknown. Make sure you have the molarity of the sodium hydroxide. Make sure I put up the right screen. So that was unknown 12. The molarity of the NaOH was 0. Whatever, you'll write it down. The initial volume was 0.00. The final was, let's just call it 16.25. Now you'll need the total amount of NaOH solution, that's B minus A, and that's the milliliters of NaOH. And now to find the molarity, you use equation 3, which you put in milliliters, molarity divided by the molarity of the HCl, which is 25. And I even have that here for you on table 1, and that will give you the molarity. And this is an important operation in any chemistry lab. When you make up a stock solution of HCl, you want to make sure you made the right one up. And don't forget, the last lab, you learned how to use KHP to find the molarity of NaOH solutions. Now, whenever you're doing a titration, you never do one. You always do it in duplicate, because they should be about the same. If you're real good, they should be almost identical. But most of you are still titration rookies. I don't expect that. And that's how you do today's lab. Except, yes, I have questions. And please read the questions carefully. And answer them. And this is today's lab. Any questions? The lab today is due next Tuesday. Hand in your labs. They're 10 points apiece. And so make sure you do that. Speaking about 10 points apiece, special announcement. Tomorrow, I'm going to have a real exciting announcement that you will want to come and listen to. 10 points announcement. All right. Any questions about today's lab? All right, let me open up. Let me close Beyond Lab Z, exit it. All right. Because I didn't have time over the weekend, I didn't feel like I was worried about Monday. I'm being honest with you. And yesterday, I didn't feel like doing anything afterward. Either this morning, I didn't have a chance to do some of the examples I wanted to get together for something under acids and bases. Hopefully you watched yesterday's video, hopefully, and still there, so you can if you missed it. But I'm going to repeat some of yesterday's. Today, I'm going to move on to organic chemistry. Tomorrow, I'll go through test number 3 answers, and I'll do a couple things and finish up for the acid-base chapter. And then I should finish up everything tomorrow. So Friday, I will go through the acid-base problem set, which means we get to the fun part of the semester. I get to talk about my main love in organic or in chemistry. I even got ahead of myself, organic chemistry. And this and the rest of the semester, we'll talk about organic chemistry. And because I've had about many decades experience in the chemical industry, I know the real world of organic chemistry, not just the academic world. And I'm going to share a lot of that with you. And I'm going to share you a lot of good stuff that you will want to know about. So it's new chapter time. Oh, I got to do this twice. A new chapter time. And that new chapter deals, and actually there are a bunch of chapters I brought together to make sense out of, and that is organic chemistry. And here are the chapters. Now, organic chemistry, what was that? Initially, that was the study of molecules found in things that were alive. That's why it's called organic. And those are plants, animals, and us, humans. Now, one of the things that makes me, let me finish the slide. In 1808, a German chemist made an organic molecule from inorganic. And that's when they had to expand the definition of organic, because how can he make something organic from inorganic? Inorganic, in means not organic from things that were alive, like sodium chloride is an inorganic molecule. Now, organic chemistry is the study of molecules that contain carbon and hydrogen atoms. Now, I don't know how many years ago, but Madison Avenue, which is the old way they used to say marketing and sales people or commercials, people who make commercials, hijacked the word organic. You see everywhere in commercials, ooh, buy our organic stuff. Or if you go to the supermarket, they'll charge you more for things that are organic vegetables. And whenever I see that inside silently, I'm just laughing my head off, because all food is organic. All food. Anything with proteins, anything with carbohydrates, anything with fats and oils, which I've just said all the three major food groups, except for the important ones like vodka, pizza, potato chips, and salami sticks, and corned beef, I should say too. But anyways, all the three major food groups are all organic molecules. So next time you see organic food, you know that word has been hijacked, because all food is organic. But now it means stuff that's sort of purer or made with less or no additives or certain types of things used to help them grow better, whether it's a plant or an animal. So anyways, that's organic. Now, organic chemistry plays a tremendous role in our daily life. How so? All the food you eat to keep you alive is organic. Now, the air you inhale, that's inorganic. That plays a role too, but organic. Your skin, the molecules that make up your skin are organic. The hair, what's left of mine, well, still a lot more than my best friend. But anyways, that's organic. The cloth that makes up the cotton and also the synthetic fibers of the blend of my top is organic. And your muscles and other things, those are all made of molecules organic, meaning proteins, carbohydrates, fats, and oils. They're all organic. I should mention, I worked for a number of years in a company that took fats and oils to make molecules that were sold to make many things in your daily life that we'll cover. Now, When we talk about organic chemistry, we're talking about carbon atoms. As I said a long time ago, my favorite element on the periodic table is carbon. Why? Because that makes up all the organic molecules in our daily life. Now, if you look at the top of the periodic table, you'll see carbon has 4 valence electrons. And in order to have an octet be stable, it needs 4 more. And that means, I don't have it on this slide, let's see something. I'll talk about it later. Carbon always has 4 bonds to it to get an octet, because you need 4 more valence electrons. Now, what's interesting, not all elements can do this. Carbon can bond to itself, form a chemical bond. And carbon can form long chains with and without branching, and also form what we call rings. And it's the basis for all life on Earth. If it wasn't for carbon atoms, we wouldn't be here in the form we exist. Now, if you're into science fiction, which I am, you can read stories about life that's based on silicon. But on our planet, the way it evolved is carbon. Now, when I talk about chains, why do organic chemists use that term? Because I think you've all seen links of a chain linked together. You can have a long chain or small links that are linked together. And the links can bend and the chain can bend and everything. Guess what? Carbon atoms in a chain can do that. And that's very important to how they interact, like in places in our body. Now, there are going to be some definitions I'm going to ask you to learn. And this is the first one. And even though my eye is cloudy, I remember it's time to and the first one is hydrocarbons. What are hydrocarbons? Those are molecules with only carbon and hydrogen atoms. So you should know what is a hydrocarbon. If I ask on a test, what is a hydrocarbon? Hint, 3 points. You should know molecules with only carbon and hydrogen atoms. So that's a hydrocarbon. And if you've been following the last number of years, discussions about climate change and air pollution, one of the most important chemicals, or I shouldn't say important, chemicals or types of chemicals that cause this pollution, probably the most widely, are hydrocarbons. Now, hydrocarbons, there's 2 types. Oh, it even says it on the slide. Uh-oh, it's evolving into that was totally awful humor Tuesday. Now, there are 2 types of hydrocarbons. And again, I'm teaching you stuff not only for my class, but for your life that you should know. And therefore, since it's that important, I'll be subtle about it. And the 2 types are saturated hydrocarbon and unsaturated hydrocarbon. Now, what's a saturated hydrocarbon? You should know that's a molecule with only carbon and hydrogen atoms in which all carbon-carbon bonds are single bonds, covalent bonds. what is a single bond? As you learned earlier for test number 2, hopefully you did, single bonds are, or covalent single bonds are sharing of one pair of electrons between two atoms. So a saturated hydrocarbon is a molecule, because it's a hydrocarbon, a molecule with only carbon and hydrogen atoms, which all carbon-carbon bonds are single bonds. Now, unsaturated hydrocarbon, an important thing is on, which means not, is a molecule with, and not, it means not saturated. And I'll explain why later we use the term saturated, unsaturated, are molecules with only carbon, hydrogen atoms. And this part right here is what a hydrocarbon is. And why is it unsaturated? Because it contains one or more carbon-carbon multiple bonds, and that's a double or triple bond. Remember, double bond Now, double bond, remember, covalent double bond is sharing of two pairs of electrons between two atoms. And here we're talking about carbon atoms. A triple bond is sharing of three pairs. Between two atoms. And for this definition, we're talking about carbon atoms again. So unsaturated has at least one or more carbon-carbon double or triple bond in the molecule. Saturated only has carbon-carbon single bonds. Now, there's one thing I should mention before we take a break, and then we've got a couple more minutes. Who's the greatest of all organic chemists? Anybody know? While you're thinking, I'm going to grab some tea. It's working. You're still cloudy out there, but it's getting there. You follow on, look up, and I asked my surgeon, but I looked up also. It takes a day or two before your pupil gets back from being dilated, and can take up a couple of days while it's still, even though since this morning it's clearing up even more. Thank you. All right, who's the greatest of all organic chemists? Mother Nature. By far, she is the greatest of all organic chemists. All you have to do is look at your skin. That's Mother Nature, organic chemistry. All you have to do is look out your window, look at a tree. That's organic chemistry. All you have to do is look at the grass or birds, animals, whatever. All the molecules there made by Mother Nature are amazing. But there's one interesting thing. Mother Nature never made anything with a triple bond. That organic chemist did. Mother Nature's double bonds and single bonds between carbon atoms, but never a triple bond. And I don't think other things she did a triple bond either. But you should remember, Mother Nature is the greatest of all organic chemists, hands down the best. And I have the most profound respect for the great things she has done and is doing. I wonder if there's a Father Nature out there somewhere. Not. All right. Now, when you hear unsaturated and saturated, remember hydrocarbon molecule with only carbon hydrogen atoms, which all carbon-carbon bonds are single bonds, and unsaturated hydrocarbon is a molecule with only carbon hydrogen bonds. That's a hydrocarbon. But what makes it unsaturated? There's at least one or more carbon-carbon, either double or triple bonds. How many of you have heard of saturated, unsaturated fats? Thumbs up, anybody? Let me go to this view. Oh my goodness, either you people don't like using your thumbs up button or you've led a sheltered life. How many of you have heard that saturated fats are worse for you than unsaturated fats and oils? Unsaturated are healthier. Now, what does that mean? Well, just what you just learned for saturated, unsaturated. In unsaturated fat, remember, this is from Mother Nature, there's at least one double bond, carbon-carbon double bond. In unsaturated, there's only carbon-carbon single bonds in those fats and oils. So the next time you're in a supermarket with friends, neighbors, or loved ones, you can say, do you know that those saturated fats are unsaturated on the label? That means there's a double bond there, there's no double bond. Because again, Mother Nature never did triple bonds. I look at the clock, it's time to take a break. Let's take a 5-minute break. I'm going to go afterward for about another 12 hours. Fooled you. Yeah, but just for a while longer, because I'm feeling not too bad. Look out. Let's take a 5-minute break and I'll see you in 5. Sorry about the late start. I was checking out my eye. It's getting better. Isn't it amazing? The healing properties of talking about chemistry? It is. All right, let's get back to work. I'm feeling good. Plus, I was checking, and from a distance, this eye is much clearer without my glasses on, which is what my eye surgeon told me would be happening. By the way, my eye surgeon is Dr. Cabin, who's located in Hoffman Estates. Anybody needing a good eye ophthalmologist for cataracts or other things, definitely check him out. If you need information about Dr. Cabin and Hoffman Estates, email me. And I don't give recommendations unless I really used it, and I have. All right, let's get back to some good stuff. Organic chemistry. Now, we were talking about saturated and unsaturated hydrocarbons. Remember, a hydrocarbon, you should know, is a molecule with only carbon and hydrogen atoms. And you should know, if I ask what's a saturated hydrocarbon, because the hydrocarbon, it's a molecule with only carbon and hydrogen atoms, and because it's saturated hydrocarbons, it's a molecule which all carbon-carbon bonds are single bonds. Now, excuse me, you should also know unsaturated hydrocarbon. Un means without, and I'll explain later on why that means that, but unsaturated hydrocarbon, since it's a hydrocarbon, it's a molecule with only carbon hydrogen atoms, and it contains at least one double or triple bond. You don't have to put down the multiple as long as you say double or triple bond. Now, the amazing thing about organic chemistry is how it's been, how should I say, evolved into a study of different types of orientation or connected atoms together found the same way in different molecules. And these we call functional groups. Functional groups are atoms connected, certain groups of atoms connected the same way by single or double or even triple bonds that always react or function the same way. If you look over here, right here, there's a door. I know I can use the door here to walk from one room to the other because I can't go through the wall. At least I'm not the Flash who can vibrate through. Yes, Dr. White likes the superheroes. When I was a kid, I had Flash comic books, Batman, Superman, but Marvel, Thor, that was the ultimate. And unfortunately, when I went to grad school, my mother threw them all out. Think of the hundred, never mind. Anyways, that's a door. Now, if you look at your front door, and mine too, it's different than that. But I know it's a door. I know the function. Right now, I'm sitting on my office chair. It's a chair. This is what the function of a chair is. If you go into my dining room, I have a butcher block table and really nice chairs, you'll see that they're different than this chair. But I know the function of a chair is to sit down. Don't use this ladder, you'll get hurt, but it's to sit down like this. And that's how organic chemistry has evolved to study. One more important area is the study of functional groups. And again, functional groups are atoms of different elements bond together in an organic molecule. Organic meaning it has carbon, hydrogen atoms also. Now, there are key functional groups. And I'm not going to ask you to, I'm not going to ask you to memorize these. I just made your life infinitely easier. There's a double bond, a triple bond. There's something called an alcohol. And one of the things I should teach you, not to scare you, I will know. In math, you know how you use variables x, y, and z. X meaning it could be a number, whatever, y or z, any kind of number, positive, negative, even imaginary. I haven't thought about those in ages. But anyways, in organic chemistry, as a variable, we use the letter R. Why R? Well, if you look at the periodic table, there are no elements with the chemical symbol of just the letter R. There are others that begin with R but have two letters, but none with R. And what R means is you've got something with carbon and hydrogens. It could be one, it could be five, it could be a million. And that's how we use R. So what I'd like to show you, and I'm not going to ask you to memorize it, but you should be familiar with, an alcohol is a molecule that has carbon and hydrogens, that's what the R means, and a hydrogen and oxygen, a hydroxyl group. OH is called, and you don't have to memorize this. So any alcohol is a carbon in a molecule with a hydroxyl group. Now, I think you've all heard the term alcohol, like stuff you shouldn't drink when you're going to drive because you'll get inebriated. There are other alcohols too that won't get you inebriated. Now, something I'd like to share with you, which I didn't do in a slide, or let me check something out. I'm going to skip ahead. I should have had this earlier. I apologize for not changing this. One of the important things in organic chemistry is to know how to draw molecules. In organic chemistry, we rarely, like almost never, use Lewis structures. They're important to understand certain things. Sometimes we use partial Lewis structures, but most of the times we don't. And how do we do that? We show carbon-carbon single bonds or other single bonds as one line. A double bond is two lines. Can you guess what a triple bond is? Three lines. Now, important thing about carbon, as I said, this is something you should know. Hint, how many bonds to carbon? 4. Doesn't that seem like 3D is coming right at you? 4 bonds to carbon. 4 bonds to carbon. So what does that mean when we draw structures? Now, there are many types of structures. The most common is condensed structures. This shows how many atoms, but does not usually show carbon, hydrogen, or carbon-carbon single bonds. Now, I've learned from just who I am, I show the carbon-carbon single bonds because that helps me draw structures that are straight instead of drooping toward the bottom of the screen or in a classroom toward the floor, which is nice. So that's a habit of mine. Let's look at, not that. Here we are. The simplest organic molecule is called methane. And I'm not going to be teaching actual names. I'll talk about a little later, so probably tomorrow. But methane has 1 carbon and 4 hydrogens. And this is the way you would draw methane. And you don't show what's called the expanded view. Because we never show, or rarely, carbon, hydrogen, single bonds. Now, methane is something important in our daily life. And the nice thing about this part of the semester is you could done it all before, but more now than ever, you can ask, why am I learning this stuff? Well, the obvious answer is someone said you had to take this course and you want to get a good grade for getting into school or a program or whatever. But why are you taking this course? Good question. Thank you. Well, let's look at methane. Methane, you also know as natural gas. And this is the molecule CH4 that you burn to cook your food in your house. If you have a gas stove, cook your food in your house. If you have a gas oven, it heats your home, because I think just about everybody in Northern Illinois, if not the whole state, uses natural gas furnace, whether you live in a home, condo, or big apartment building. They all use natural gas, which is methane, CH4. Back when I was really young, I think through high school, maybe late grade school, late 1950s, that was a long time ago. My parents in the home we lived in had an oil burning furnace. And somewhere around the mid or early 60s, we changed over to gas. And now back then you used to see oil trucks delivering oil to your house to burn for the winter. Now you don't, because you got gas line. And you burn natural gas, methane, CH4. Remember, that's a saturated hydrocarbon because it's only got carbon-carbon single bonds. There's no bonds at all, and only hydrogens. Now, let's look at another molecule. And this is propane. And notice propane has 3 carbons and 8 hydrogens. This is called the empirical formula, which we've used up to now. Which in organic chemistry is totally useless. This I will call the structure, which in organic chemistry we use. Now, first of all, why learn about propane? Well, propane has been used and is used as the gas in the white tanks for your barbecue. If you have a gas barbecue or know someone who has one, and you see the white tanks that you can buy or get refilled, or I guess nowadays you can also exchange just about everywhere. It's filled with propane. And this you burn to cook food and get heat on your barbecue. Now, there are 4 bonds to carbon always. And let's find out, am I lying to you about that? I'm going to show the expanded view for propane. And if we look at carbon number 1, how many bonds to that? Well, let's count them. 1, 2, 3, 4. There's 4 bonds to carbon. Let's look at the next carbon. Carbon number 2, this one. How many bonds to carbon do you see? I'm going to let you count first. Excuse me. All right, time's up. Let's count it. This is one bond to this carbon. This is two. This is three. This is four. So there are 4 bonds to that carbon. Now let's check the last carbon. Oops, I just wiped out a carbon. And if we look at this carbon right here, it's got 1, this bond, 2, 3, and this one makes 4. So that also has 4 bonds to carbon. How many of you have ever seen those little plastic cheap lighters with the liquid in it? Or if you want to spend money, you can buy fancy ones, gold. I have one like that. I used to be a heavy smoker. I also have my Zippo lighters, but I gave my smoking up, thank goodness, in 1985. But anyways, how many of you have ever seen those, or the longer ones that you use to light your fireplace with? And if you look in the base of the longer one or the smaller one, you'll see a liquid. And that liquid is called butane, which is why they're called butane lighters. Now, butane is a saturated hydrocarbon and has 4 carbons. A skill I'd like you to have how do you draw in the hydrogens for butane? This is called butane. And you know there's 4 bonds to carbon. So if we look at the first carbon right here, how many bonds do we see? 1, but there should be 4. Now we're going to go to some real high level math. If there are 4 bonds to carbon and you see 1, the remainder are hydrogens. Do you need your calculator? 4 minus 1 is 3. So I know there should always be 4 bonds to carbon. In this carbon, I have 1, so I now need 3 hydrogens. And now 3 hydrogens plus this bond right there, there are 4 bonds to carbon. Let's look at this carbon right here. How many bonds to carbon are there? Let me write that 3 better. And here, there's 1 bond here and 1 bond there. Well, there's always 4, yes, 4 bonds to carbon. And how many bonds do we see in this carbon? Already there are 2, but since there has to be 4, the remainder are always hydrogen. And high-level math time, 4 minus 2 is 2. So I should do this. Now, let's do this one right here. And the first thing is, how many bonds to this carbon do you see? Time's up. The answer is 2. This one and this one. So how many bonds to carbon should there be? By the way, I'm ambidextrous. I can do it with either hand. 4 bonds to carbon. 4 bonds to carbon. So how many hydrogens should be on this carbon? Well, there should be 4 bonds to carbon. There are already 2. So 4 minus 2 is the number 2. So this should have 2 hydrogens. Now, being the nice person I am, why don't you figure out how many hydrogens should be on the last carbon? Are you ready for a special announcement from Dr. White? I was just looking at that and testing it, and my doctor said I'd have to remove this lens. I have other glasses. When I went like this I was reading the screen clearly. This one wasn't. It's working. Thank you, Dr. Cabin, and all the nurses there too. I'm a happy camper. All right, let's take a look at this carbon. How many bonds to carbon should there be? 4. How many do you see? 1. This one right here. 4 minus 1 is 3. And that's the structure of butane. That's the molecule that is that's the liquid in butane lighters. I'm going to ask this question. Give me a thumbs up if you know about this. How many of you have ever seen a gas station by the pump's octane number? Uh-oh, it's thumbs up, people. Strike. I mean, none of you have ever seen an octane number or the number by the pump in a gas station? Oh, thank you, Ruben. Well, let's learn about octane number. Back when they first started selling gasoline and they had, the engines in the cars about the 1900, 1905, they found the gasoline with the most octane, and there's a word I'll teach you later about isomers of octane, gave the best results. The engine worked the best. It didn't knock and make strange noises and do other things. Since then, they found other things they can add to gasoline. But octane number comes from the molecule octane. And octane has 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And this molecule is, when they first started making gasoline, they found that was the best. Now, it's time for Dr. White to share with you. Why don't you draw in the hydrogens for each of the 8 carbons in octane, 3 points each. Remember, there's always 4 bonds to carbon. Oop, I got to get that finger fixed. Now it is 4 bonds to carbon. Your turn. Remember, 4 bonds to carbon, heavy math. Each line is a bond to carbon. Let me resend a poll, give you a chance. I think everybody's done, so I better get to work. All right, how do we do this? We know there are 4 bonds to carbon. The first carbon, we see 1 bond, 4 minus 1 equals 3. So the remainder bonds in an organic molecule are hydrogens. This carbon, we see 2 bonds, and 4 minus 2 equals 2. So I can put in 2 hydrogens. The same here, 1, 2. And therefore, I have 2 hydrogens, same here, same here, same here. Sound like a broken record. Most of you have never heard a broken record. 2 there. And let's look at the last one. There's 1 bond to that. There should always be 4 bonds to carbon. 4 minus 1 is 3. And we show that. Now, one of the interesting things that I should warn you about, organic chemists are lazy. When we don't want to draw stuff, if we can find a lazier, easier way, we do. And we do it in other things too. We're lazy. We are. I am at times. And there's a way of drawing condensed structures with parentheses. This I won't put on a test, but you'll see it on like Wikipedia. And that's the same as condensed, but uses a pair of parentheses with a number to show repeating units of a molecule. And let's look at this. This won't be on a test, but I do want you to know about it so you're familiar with it. Now, if we look at octane here, notice there's a repeating unit of molecules. 1, 2, 3, 4, 5, 6. This is because CH2. It's repeated here, 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 and here. Now, using parentheses, which I don't do when I teach organic at your level, at my level, I use them all the time. And later on, I will use them when we talk about certain large molecules. I could rewrite it, CH3, and then I have all these repeating. So to show that, I'll have a bracket or parentheses, CH2. How many times does it repeat? 6 times. So I'll use a subscript, 6, and CH3. And this is how organic chemists would, one way of drawing this. And that's useful, but I won't do that in this class. Now, we can have organic molecules that are cyclic. Cyclic like a bicycle, bi, two, cycle, circles. And the two wheels on a bicycle, that's why it's called a bicycle. And there's something called cycloalkanes. And those are represented by polygons, many, gon-sided things. And here we use what's called the line method. And a bend in each line is a carbon. And also you can use the line method for other things. End of each line is a carbon atom, and intersection of each line is a carbon atom. Hydrogens, when you use the line method, are not shown. And a lot of times in the internet, this is how you'll see it. Now, I should warn you, Dr. White and Mother Nature love cyclic compounds, organic molecules with rings. We love them. I did my PhD thesis on a special type of cyclic compound, very complex, and also certain functional groups, which we'll come back to. But let's look how to draw and count the number of carbons in a ring. Now, if I were to use actually showing the carbons in a ring, and it doesn't have to be round, but we still call it a ring. First of all, I'm going to let you have some fun. Tell me how many carbons are in that molecule I just drew. All right, time's up. Let's count them. You look for the C, carbon, 1, 2, 3, 4, 5, 6. Why does each carbon have 2 hydrogens? Well, there's 4 bonds to carbon. This has 1, this has 2. Therefore, this carbon has 2 bonds to carbon, 4 minus 2, 2 hydrogens. Now, organic chemists are lazy, and this is a lot of work to draw. We don't. How do we show that same ring? By this, let me draw another one. I actually have software that does a better job. That's better. How do you know these two are the same? In the line drawing, each bend in a line is a carbon. So we have 1, 2, 3, 4, 5, 6. Now, this is called cyclohexane, and I will not be teaching you, I wish I could, but I don't have time, how names are created and used, but cyclohexane. Now, one of the interesting things on the internet is Wikipedia. I remember when it first came out, I used to call it Wikipedia. My class students would say, no, it's Wikipedia. And they finally taught me how to pronounce it correctly. Now, over the years, Wikipedia has been so heavily policed by PhD chemists and other chemists, but I know for sure organic chemists, including myself, and yes, I have the credentials recognized by Wikipedia, I almost said Wikipedia, that if I request a change, they change it. But it's been many years and I can only talk about organic chemistry and really most chemistry too, but for sure organic chemistry, since I've seen any kind of even minor mistake, which has to be requested to change. So when you go to Wikipedia, look up organic chemistry, anything, guess what? You'll find true facts. If you look on your screen, I use Google to find cyclohexane Wikipedia. Now, if you look over to the right, does everybody see right here where my cursor is in the 6-line structure or hexagon? Thumbs up, people. Can you see it? Uh-oh. All right, now, can you see cyclohexane on your screen? Thank you, Amber. Test. Is anybody out there? Well, anyways, if you look over here, this is the structure of cyclohexane. When I put my cursor, it even says that. Now, these other ones show, this one is totally useless, 3D to me. These two show what we call stereochemistry, how a molecule actually looks in real life in 3D, which I won't be teaching here. But notice here, cyclohexane, 1, 2, 3, 4, 5, 6. And that's how you draw a molecule. Now, somebody give me a thumbs up. I might have, but now I'm remembering I might not have. Let me just go back to here. I'll go to gallery view. Did I teach you about which gasoline is the best? I talked about that in this class. I know I've done it in organic. Give me a thumbs up or say on chat. That'd be even better, yes or no. Did I? Thank you, Ruben. But let me do instant replay. Now we're talking about organic chemistry. I'll do it again. The best gasoline, and gasoline is a very complex mixture or solution, you know what a solution is now, of organic molecules. Now, not all gasolines are the same quality. The best quality, and how do I know this? Because years ago, I worked for a company that made special additives for the petroleum industry, your gasoline companies. And I got to visit those companies and talk to their research and development people when we were trying to sell them our molecules. And I always asked, what's the best gasoline? And everybody hands down, Shell is the best, and it still is. Right, almost equal is Mobil. At the very bottom, don't buy it all unless it's an emergency, is BP. Back then, it used to be called Standard. Why is BP the worst? Well, if you go back a couple of years, like 3 or 4 years ago, in Indiana and in Illinois, by Gary, not far from here, the BP refinery there made gasoline and sold it to the gas stations right around that area. That was so awful. Are you ready for this? It destroyed the car engines of close to 4,000 people. That's got to be pretty bad gasoline. And that and another reason I'll tell you later on this semester. That's why Dr. White, unless it's an ultimate emergency, will not go into BP. Now, one other thing I think I mentioned, but repetition is good for your life. If you look on your screen, you'll see Gas Buddy, and their URL is www.chicagogasprices.com, and then you can put in a zip code. And if I do, it's been a while since I've done this. I think I nailed it. If you look at, I put in the zip code for Glen Ellen, and right by COD, there's a Shell station on Roosevelt by Park. They're selling $3.44. And you can look at other gas stations in the area, which are a lot different priced. If we look at the other school I teach at, which I don't go to because I'm on Zoom, this is in Elgin. You can see different. Here's the top near the area. And in fact, this Marathon, and there's a Shell right across the street from it, I've used for many years. You can see different prices, and they vary. And this is a great tool. I live in the Schaumburg area. And you can see at this Walmart compared to, this is a mobile by my house, that's a huge difference. The Meijer Costco I go to, it's still a lot lower. Sometimes one gas station area is 10, 15 cents a gallon less than another. And this is a good place to look for it. Now, some other rings that are in our daily life is this ring. Oops, let me draw it better. Now, I'm going to ask you how many carbons are in that ring. Your turn. Time's up. How do you count carbons when you're using the line method? Every bend in a line is a carbon. Every end of a line, well, this only has bends, so let's count them. 1, 2, 3, 4, 5. And this is called, this 5 carbons. And this is called a ring. By the way, how many of you have ever played Monopoly? This is called, by the way, cyclopentane. You don't need to remember that, but I'll put it down because it makes me happy. And whenever I see a cyclopentane ring, I think of the little green houses in Monopoly. When I was about 6 or 7, my older sister and I, my younger sister wasn't born yet, played cutthroat Monopoly. If one of us got a cold, the other would get the cold, and we'd stay home sick from school, and we'd play Monopoly. And we played cutthroat Monopoly. What's that? Well, when someone went to the bathroom, the other person would steal money from the bank. She did too. So you tried not to go to the bathroom while you were playing Monopoly with either of us. But cyclopentane. It reminds me of little greenhouses and Monopoly. Now, I should tell you, Mother Nature and Dr. White love 6-membered rings and 5-membered rings. And I'll teach you later that our hormones, the steroids, contain 3 6-membered rings and 1 5-membered ring. Again, our steroids, your hormones, things that do things like the hair on your face, mine, other things that control things in your body, have 3 6-membered rings and 1 5-membered ring. With that, considering I just had my eye surgery yesterday, things are getting better. Oh, they are. Hold on, I forgot. Oh my God, when I do this, hold on. Open up. Doesn't want to open up all the way yet. There it is. This is pretty clear. I don't need this anymore. With that, I think I got to end today. Tomorrow, I'll go through test number 3. Some of you should go back and look at my review video for test number 3 and go back and do practice problems. I'll talk more about that, but I'll go through test number 3. Remember, I'll cut it out of the video. And then also, any more time, I'll get back and finish up stuff from pH chapter, acid-base. Remember, Friday, I'm going to go through the acid-base problem set, because next week, hold on, while are you holding on to something? Anybody has another phrase that I should say when I say, give me a minute or two while I look for something? I guess I could say, give me a minute or two while I like hold on better. Yeah, next week is Thanksgiving. And Thanksgiving means there's no class on Wednesday here, on Thursday, or Friday. So we got a lot to do before test number 4 is coming up. I think it's the first week in December. I have it on a Monday because of Thanksgiving and all that, but I'll have to check. But this Friday, I will be doing the acid-base problem set. And with that, I survived. Things are going well. I'm going to say, gang gesund. Bye now.